Good afternoon, everyone. If you're just joining us, I was just encouraging everyone to ask any questions they might have about the element discussion. That was on your schedule for last Friday. And if you haven't completed it yet, be sure to put it on your to-do list. Remember to follow the directions and provide all of the required information on your element. And then also be sure to provide constructive feedback to at least 2 other posts. I was looking through the discussion posts this morning, and I saw some good stuff, but it looked like only about maybe half the students so far have made a post. So be sure to do that if you have not already done so. I would be sure to get this assignment done by Wednesday. So good afternoon, everyone. Mrs. Palazzolo here. Happy Monday. I hope everyone had an awesome weekend. I hope you're ready for another great week here at GCA. I hope everybody's ready to get started for our physical science class. Let me hop off of here, enlarge this back up. So today we're going to be talking about radioactivity. And something I want you to look for, especially when you get to your Canvas lesson warm-up, is the answer to this question. What fuels a space probe? You know, we send these space probes out there, you know, to explore the planets. And then not just that, but they go out there further beyond the planets and keep going and going and going. What fuels them? What fuels those space probes? So be on the lookout for that answer. And today is Monday, August the 26th. Keep in mind PARC, a nice acronym here. P stands for participate. Be sure to actively participate in your classes. Active, engaged learning is the best. Be sure to attend all of your required classes. R stands for read. Read and respond to your emails. And most of these are occurring now in Canvas. So be sure to check your Canvas inbox daily. And C stands for complete. Be sure to complete all of your assignments and assessments. Here is our GCA vision and mission. And we've got a knowledge check for you. Bernadette here reminds you that you can use your emojis to respond. Your emojis are down here in the bottom left corner. So check down here, look for that blue strip, see that smiley face, click on that. And your knowledge check question is, how are most of the elements on the periodic table classified? And be sure to open up your handy dandy periodic table of elements. Hopefully you have it color-coded. So this question is pretty easy for you. Be sure to utilize those periodic tables of elements there in Canvas. You'll find them under course materials. There's 2 of them. One is kind of blank, and it's the same kind of periodic table you can expect to use on the physical science EOC. I encourage you to download it, print it, write notes on it, color code it for the different types of elements, like the ones that you see here. Put notes on it, make it your own. The other one already has some notes on it, but again, download it, print it, save it, utilize it, add more notes to it, color code it, make them both your own. So again, our question is, how are most of the elements on the periodic table classified? Give me that smiley face if you believe it's non-metals. The OK sign if you believe it's noble gases, that volume for metalloids, and the turtle here for metals. And let's go for 100% participation. So I expect to see emojis for everyone, and I'm not yet, so be sure to get those responses in. Remember, your responses are hidden from view, so if you're not sure, please take a guess. So Zuri and Zan, get your response in, please. Thank you. Piper, need a response from you. And Natalia. Kaylin, need a response from you. Justin. Kay, need a response from you. Hashem. Thank you. Camden, need a response from you, please. And Anaya, get those responses in. Okay, I should be seeing lots of my favorite emoji here, lots of turtles, because that is the correct answer. Most of the elements on the periodic table are classified as metals. So great job if you got that correct. Let me know if you have any questions about that. If not, we will move on. I've got one more knowledge check here for you. Non-metals tend to boil at smiley face if you believe it's moderate temperatures, okay sign for varying temperatures, the volume for high temperatures, and the turtle here for low temperatures. Non-metals tend to boil at what? Let's go for 100% participation. Everyone respond using your emojis, which can be found in your bottom left-hand corner. Do, 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 do. Okay, still waiting on responses from Anaya and Anastasia. Get those responses in, please. Camden, Demetris, Justin, get your response in. Kaylin, Zan, if you're not sure, please take a guess. Okay, once again, my favorite emoji here is the correct answer. Turtle, low temperatures. Non-metals tend to boil at low temperatures. If you did not know that, please be sure to review your Canvas lesson on non-metals and add its characteristics and properties to your notes. Do we have any questions about that? Let me know if you have any questions. If not, we will move on. So here are our unit goals, and this is from the Georgia Standards of Excellence. So we are focusing on Standard 1, and today our goals is to learn about radioactivity. So be able to answer, what is it? Summarize its discovery, explain radioactive decay, perform half-life calculations. Not as bad as it sounds. And describe uses of radioactive isotopes. And I've got a great video here from Teacher's Pet that will help you do all of that. Okay, I hope you enjoyed that video. By the way, if you missed part of it because you're just joining us, you can find the full video there in the Explore and Learn More page of your Canvas lesson. So I'm going to give you some time now to dive into your Canvas lesson. Be sure to look for that to answer what fuels a space probe in your Canvas warm-up. Utilize those guided notes to help you take good notes while you're working through the lesson. And you should be able to get through the warm-up and maybe most of the instruction. And then we'll meet back for like the last 10 minutes of class to recap, answer your questions, and assess. And be sure to put any questions you have about the content on the whiteboard. Okay, I'm not seeing any questions on the whiteboard. So please be sure to add the following to your notes, and you will find this in the summary of your Canvas lesson. So radioactivity is the spontaneous discharge of radiation from an unstable nucleus, first discovered by Anton Henry Becquerel and later investigated by Marie and Pierre Curie. Some isotopes are radioactive, which means that their nuclei are unstable and change spontaneously, releasing particles and energy. And this process is called radioactive decay and is predictable and has many applications. Now, the video went over several applications. Do you remember what they were? Feel free to grab the mic or tell us in the chat box. What are some applications of radioactivity? Just be sure to watch, I'll post a recording of this session. Be sure to watch that and be sure to finish your lesson in Canvas. So the video talked about many applications, and your lesson does too. What are some applications of this radioactivity? You're welcome. Feel free to grab the mic or tell us in the chat box. Were you able to see the video that I showed earlier? That's in Canvas as well, if you need to watch it later. Okay. When you hear about like scientists finding fossils, how do they know how old these fossils are? Remember the video talking about the carbon dating? So they're able to use carbon-14 that the organism consumed prior to death, and they use that to date the fossil. There's also quite a few medical applications nowadays that use radioactivity. X-rays, PET scans, different imaging techniques, as well as treatments. Did anybody catch the answer to this? It was in your warm-up. What fuels a space probe? Again, feel free to grab the mic or tell us in the chat box. The answer to this one was in the warm-up in Canvas. Anybody get the answer? Yep, radioactive particles. Anybody catch the exact ones? You know, we send these space probes out. They explore various planets. And then some are even going beyond our solar system. So they are powered by radioactive elements. If you haven't watched through the warm-up yet, see if you can catch the name of the exact one. Okay, let me minimize this and add this over to here to the whiteboard. And then we'll enlarge that. And you've got tools. See if you can't match the term to its definition. Go ahead and use your whiteboard tools. You can make that just a little bit bigger. There we go. Use those whiteboard tools. Match the term to the definition. That would depend, Shayla. Kind of. You would need to be a little bit more clear in what you meant by nuclear activity. So let's see. Mutation, again, not sure what you mean by mutation. Half-life is definitely a part of a whole. Let's see how we're matching these up. I'm sorry, no, half-life is definitely the time it takes for half of the radioactivity atoms in a substance to decay. Percentage is a part of a whole. I was mixing those two up there for a second. Okay, this looks pretty good. Let me minimize this. And we'll go back up to here. So I think I cleared out, yes, your emojis. Using your emojis, so smiley face if you're feeling pretty good. You've got this down. Looking at your level of understanding here. Okay sign if you're okay. Maybe you need to review a little bit. Volume button. Definitely need to review. Level of like 1 here with the turtle. And help me, I'm lost with the X. If you are like, if your level of understanding is like between 0 and 2, please check out the Breaking It Down resources under the Explore and Learn More. If you're up here, level 3 or 4, think you've got it, then please check out the Explore and Learn More videos and interactives. Let me know if you have any questions or need any assistance. Be sure to finish up that Canvas lesson, take good notes. And if you don't have any questions or need assistance, you're free to exit the room, get ready for your period 7 class, and I will see you tomorrow.